Hello, class. Today we're going to look at some of the tools we'll be using in this course. The first tool is Python, the programming language we'll use for this course. Python is a high-level language created by Guido van Rossum in the late 1980s and first released in 1991. Python was designed to be simple, readable, and beginner-friendly, using indentation instead of symbols to structure code. Over time, it has grown into one of the most popular programming languages in the world, used in areas like web development, data science, artificial intelligence, and automation. The next video will demonstrate how to install Python on Windows 10. If you're using Windows 11, you can also download Python directly from the Microsoft Store for an easier setup. On the course website, you'll find additional tutorial videos covering installation on macOS and Ubuntu, a popular version of Linux. When you run a Python program, your code doesn't go straight to the computer. It actually takes a few steps along the way. First, Python looks at your text and figures out the structure, kind of like checking the grammar of a sentence. Next, it turns that code into something called bytecode. Think of bytecode as Python's own shorthand, simpler instructions that Python understands really well. Then, the bytecode goes to the Python virtual machine, or PVM. The PVM's job is to read those instructions and translate them into machine code, the actual zeros and ones your computer's hardware speaks. That's when your program really runs. So in short, your text, bytecode, virtual machine, machine code. To write Python programs, all you need at the most basic level is a text editor to type your code and the Python interpreter to run it. This makes Python simple and accessible. You can get started with just these two tools. However, most developers use an integrated development environment, or IDE. An IDE is a single application that combines a text editor with additional programming tools all in one place. It usually includes syntax highlighting and autocompletion to make code easier to read and faster to write, error detection while you type, debugging tools to step through your code and fix issues, project management features to handle multiple files and libraries. In short, while Python can run from any plain text editor, an IDE provides a complete workspace that makes coding faster, more organized, and less error-prone, especially for larger projects. In this class, we will primarily use two IDEs, Google Colab and Visual Studio Code, VS Code. VS Code is a free, lightweight, and widely used IDE developed by Microsoft. It runs on Windows, macOS, and Linux, and supports many programming languages, including Python, through extensions. We will use VS Code because it provides a professional coding environment with powerful features such as syntax highlighting, auto-completion, an integrated terminal, and built-in debugging tools. These features make Python development easier, more efficient, and much more enjoyable than working in a plain text editor. Besides VS Code, there are other popular IDEs in the Python ecosystem. Anaconda is a Python distribution that comes bundled with many scientific and data analysis libraries. It makes it easier to manage packages and environments, especially for data science. Jupyter Notebook is an interactive environment where you can mix code, text, and visualizations in one document. It's very popular in research, teaching, and data analysis. Google Colab is basically Jupyter running in the cloud. It requires no installation, and you can run Python code in a web browser with free access to computing resources. For this class, we will not use Anaconda or Jupyter, but it's important to know them since they are widely used in the Python and data science community. Anaconda Cloud is an online platform where you can store, share, and access Python packages, environments, and even Jupyter notebooks. For example, if you create a custom environment with specific libraries, you can upload it to Anaconda Cloud so that someone else can download and use the exact same setup. So in short, think of Anaconda Cloud as a hub for Python tools and environments that makes sharing and collaboration much easier. The second IDE we'll be using in this course is Google Colab. Google Colab, short for Collaboratory, is a cloud-based coding environment provided by Google. It lets you write and run Python code right in your web browser without installing anything on your computer. It's built on top of Jupyter Notebooks, which means you can mix code, text, and visualizations in the same document. Another big advantage is that Colab gives you free access to GPUs and TPUs, which is really helpful for data science and machine learning tasks. The two main IDEs for this class are VS Code and Google Colab. Artificial intelligence has become part of everyday tools we use, and several major companies are leading the way. Microsoft has integrated AI into many of its products. For example, Copilot is built into Microsoft Office and Windows to help you write, summarize, and generate content. Microsoft also partners with OpenAI to bring advanced AI models into Azure Cloud Services. Google develops its own AI tools, including Gemini, previously Bard, which is their conversational AI system. Google also powers AI features inside Gmail, Docs, and Google Cloud, making it easier to draft text, analyze data, and search information. OpenAI is the creator of ChatGPT and the GPT family of models, which are widely used for text generation, reasoning, coding assistance, and more. Many applications you use today actually run on OpenAI's models behind the scenes. Anthropic is another leading AI company known for its assistant called Claude. Claude is designed to be helpful, reliable, and aligned with human values, and is popular in businesses and research environments. So in summary, Microsoft, Google, OpenAI, and Anthropic each build AI assistants and tools, often integrated into platforms we already use. These tools are rapidly becoming everyday companions for productivity, learning, and creativity. Many people worry that artificial intelligence will replace programmers. The truth is more nuanced. AI tools like ChatGPT, Copilot, or Claude can already write code, explain errors, and suggest solutions. This means some routine or repetitive programming tasks will increasingly be automated. However, programming is more than just typing code. Programmers design systems, solve complex problems, understand user needs, ensure security, and integrate software into the real world. These tasks require creativity, judgment, and context, areas where humans are still essential. Instead of replacing programmers, AI is becoming a powerful assistant. It speeds up coding, helps with debugging, and lets programmers focus on higher-level problem solving. In the future, those who know how to use AI effectively will be more valuable, not less. So the message is, AI won't replace programmers, but programmers who use AI may replace those who don't. In the tech world, the phrase code monkey, a derogatory term, is sometimes used to describe programmers who mainly do repetitive, low-level coding tasks without much creative or critical thinking. These are jobs where the work is mostly about translating instructions into code rather than designing systems, solving complex problems, or making decisions. Because AI tools are very good at generating code from clear instructions, these routine tasks are the first to be automated. AI can already write boilerplate code, generate templates, and handle repetitive patterns much faster than a human. That's why so-called code monkey roles are more vulnerable to being replaced by AI. On the other hand, roles that involve creativity, design, problem solving, and understanding the bigger picture are far less likely to disappear. In fact, AI frees programmers from the tedious work so they can spend more time on the interesting, high-value parts of software development. A software architect is a senior developer who designs the overall structure of a software system. Instead of focusing on individual lines of code, they decide how all the pieces fit together, what technologies to use, how data flows, how components interact, and how the system will scale and stay secure. In the age of AI, this role becomes more valuable than ever. Why? Because AI can generate code, but it cannot fully understand business goals, user needs, or long-term trade-offs between cost, performance, and security. Those require human judgment, creativity, and domain knowledge. As AI takes over repetitive coding tasks, organizations will rely even more on software architects to guide projects, make high-level decisions, and ensure that systems are reliable, ethical, and aligned with real-world needs. So while entry-level coding roles may shrink, the demand for strategic thinkers like software architects will grow. As you just saw in two different examples, one using VS Code with Copilot and the other using ChatGPT, I asked the AI tools to write a Python program to print some messages. Both of them produced what is known as a Hello World program. A Hello World program is the traditional first program when learning any new programming language. Its only purpose is to display the words "Hello World" on the screen, which confirms that the programming environment is set up correctly and working. In Python, this is done using a command that tells the computer to print text to the screen. The text we give it is simply the phrase "Hello World." You don't need to worry about all the details yet. For now, the important point is that this is your first Python program, and it shows how easy it is to begin coding in Python. In the Hello World program we just saw, the word print is something called a function. Now, I know that term may sound technical, but here's the simple way to think about it. A function is like a small machine or recipe. You give it an input, it follows a set of steps, and it produces an output. For example, imagine a vending machine. You press a button, and it gives you a snack. The button you press is like the input, and the snack you get is the output. You don't need to know exactly how the machine works on the inside. You just know what to give it and what you'll get back. That's exactly what happens in programming. The function called print is a built-in machine in Python. You give it some text as input, and its job is to show that text on the screen as output. So whenever you hear the word function, just remember, it's like a ready-made tool that does a job for you when you call on it. In more technical terms, a function is a block of organized, reusable code designed to perform a specific task. You can think of it as a way to group instructions together so that they can be used whenever needed, without having to rewrite the same steps over and over. Functions are powerful because they let programmers break down complex problems into smaller, manageable pieces. Rather than solving everything at once, you solve each part with a function and then combine them to create the full solution. In Python, there are two main types of functions. Built-in functions. These come packaged with Python and are ready to use immediately. Common examples include functions that display text, calculate a sum, or return the length of a list. User-defined functions. These are the functions you create yourself. If Python doesn't already provide a function for a specific task, you can write your own and reuse it as often as needed. Now let's take a closer look at built-in functions. These are functions that Python provides automatically. You don't have to define them or import anything. They're simply ready to use as soon as you start Python. They cover a wide range of everyday tasks, such as doing math, converting data from one type to another, handling input and output, and many others. Some of the most commonly used built-in functions are print, shows text or results on the screen. Len tells you the length of something, like how many characters are in a string or how many items are in a list. Type tells you what kind of object you're working with, and range generates a sequence of numbers that you can use in loops or calculations. These functions are part of what makes Python so beginner-friendly. You can accomplish a lot right away without writing everything from scratch. Alongside built-in functions, Python also allows us to create our own. These are called user-defined functions. They're useful when you want to package a set of steps that you'll need more than once, or when Python doesn't already provide the exact tool you need. We won't dive into how to write them just yet, but later this semester we'll learn how to create our own functions. That way, you'll be able to design custom tools tailored to the problems you're solving. Thank you. This presentation was prepared by June Lee with the assistance of AI technology.